Okay, so we're going to review scientific notation. So there's lots of different ways to teach scientific notation. I'm going to try to go with the most basic way, right? This might not be how you learn it in math. It might not be how you learned it before. But this is what I'm going to show you, I think, the most simplistic way to do scientific notation. Okay? So let's think about what scientific notation looks like to begin with. M times 10 to the n. This number right here always has to be between what? Has to be between 1 and 10. Okay, so x has to be less than 10, or really m, has to be less than 10, but greater than 1. Okay, that's the rule for this. Okay, has to be less than 10, but greater than 1. So as I start looking at this number, and I know I want to put it into scientific notation, I have to figure out how to put my original decimal place, which is right here. I have to figure out how to get it to a number that's between 1 and 10. So where would I place my decimal place, between what two digits, to get it to be between 1 and 10? 8 and 4, right here. Okay, 8 and 4. Okay, that would give me, let's say we ignore that last decimal place for right now, ignore that. Right, then I'm really at 8.46428000, right, if we're ignoring that last decimal place. Are we on the same page so far? Yeah. Okay, so now we have to think about how many decimal places did we move, or how many times 10s would we do to get it back to our original number? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 decimal places, or 8 times 10s, between the starter decimal place and the new decimal place. Okay? So that means we're going to go with times 10 to the 8. And is it a positive 8 or a negative 8? Positive 8. This number that we started with, our original number, 846,428,000, that number is larger than 10, which means we have a positive exponent. That's always how it works. I'm not going to teach you move to the left is a positive, move to the right. I don't do that, okay? The bigger the number means a positive exponent. A smaller number than 1 means a negative exponent, okay? So now let's say we just want it to be 2 decimal places. Okay, it will usually specify how many decimal places we want to put into. Let's just say we want 2 decimal places, which means we would be 8.46. I know. So here's the issue with scientific notation. Here's the issue, right? Here's our original number. $846,428,000, right? That's our original number. And we just cut it down to have 2 decimal places. So when I expand this number back out, 846 times 10 to the 8th, that means I'm losing a lot of the exactness of my number, right? This was my original number. This is what I'm representing with this scientific notation. So the fewer number of significant figures we have in scientific notation, that's taking away some of the exactness of our number. But that's just how it goes. Okay? So, do we need to show you how I got to this number right here? Going out of scientific notation? Okay. Does that make a little bit more sense? Okay, let's do some practice with this then. Okay? So this number and this number technically are all the same. Right? It's just a representation of that number. If we wanted our number to be even more exact, right, we could say 8.46428 times 10 to the 8th. And we would still get, we would get back to exactly that number. Okay? This would just be if we could allow, 6 significant figures. Okay? All right, let's try some practice ones. Put that into scientific notation. All right, Grant, why don't you tell me what you got? Why don't you just try it anyway? I'm sure it's not. You can be confident.
4.94 times 10 to the 5th.
Perfect.
I was right.
You're right. It's perfect. Okay? That's why I said be confident. Okay, how many of you went times 10 to the 7th? Okay, we don't go past the original decimal point. Okay, so we don't ever go past where the original was. Just because there's extra decimals on the end, we don't go all the way to the end of the number. We go original decimal point to between 1 and 10. Okay, so times 10 to the 5th. Good. And I asked specifically for 3 sig figs here, which is why we cut it off after that 4. Okay? Let's try another one. Nope, that's not what I want. There you go. Okay, go ahead and put that one into scientific notation. Let's do 3 sig figs again. 3 sig figs.
4 9 times 10 to the 8.
Does everyone agree? Anyone have anything different? Natalie, what'd you have? To the 10th? To the 7th? Anyone have anything different? Yeah, Hannah?
6.50 times 10 to the 8.
I had this. 6.50 times 10 to the 8th. So why is it 50 instead of 49? Yeah, see this 8 that's after the 9 here? That means we round that up. Okay? We round that up. If it had been a number underneath a 5, right, which it had been for the last 2, we can leave it. Okay, and let me show you why. It should be times 10 to the 8th, by the way, because we're going 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's why it's 8. Let me show you why to the 6.50 is better than 6.49. Okay, if I would expand this number out, 649000000, right? That's what the number would be. If I would expand 6.5 out, 6.5 times 10 to the 8, I get 650000000. Which of those numbers is closer to the original? The bottom one or the top? The bottom, right? 600 and, let's see how many zeros we got here. 650 million is much closer than 649 million. See this 800-something thousand tacked on at the bottom puts us much closer to 650,000 than 649,000. Okay? Or million or whatever number we're at. Does that make sense? Okay, so the number we're trying to show has to be closer to the number we put in scientific notation. Okay? Again, you lose some of your exactness when you put it in scientific notation. That's just how it goes. Okay, but it should be close to the number that you're trying to express. Okay, so this should have been our final answer, 6.50 times 10 to the 8th. Okay, let's try some smaller than 1 now. Let's go 3 sig figs in scientific notation. You need to put that decimal place, right? Here's our original. Put it between 1 and 10. So what 2 digits would it need to go between? 4 and 9. Okay, and then we decide how many to remove it. 1, 2, 3, 4, 5, 6. So we're at times 10 to the 6th. Is it positive 6 or negative 6? Negative 6, because that number is between less than 1. So that means our final answer should be 4.96 times 10 to the negative 6th. If it's 3 sig figs, right, here's 3 sig figs. Okay, so since I asked specifically for 3 sig figs. If I had asked for 2 sig figs here, what would our answer had to have been?
5.
5.0 times 10 to the negative 6th. Okay, because 5.0 would have been a lot closer than 4.9 times 10 to the negative 6th. Okay, so 5.0 would have been 2 sig figs. This is 3 sig figs. So the more number of significant figures you're allowed, the more exact your answer is going to be. Okay? Let's try expanding some now. Or I'm sorry, yeah, I'm going to give you in scientific notation, you're going to give me the actual number. Okay? Okay, so for each of those numbers, you're going to put them in their regular form. So for the way we think about expanding these, right? Does anyone have an answer they want to share with me first of all before I show you how we get there? Or would you rather show first? I'll just show you first. Okay. When I think about expanding that number, I'm going to go ahead and write what I have, right? 3, 4, 9, 7. I knew I moved it 6 places from my ones place to get it to be bigger than 1 or bigger than 10 or smaller than 1. What am I trying to move it to? This exponent is positive, so that means the number I'm trying to express is what? Bigger than 10. So that means my zeros are going to go this way, right? I'm going to add zeros to the end of my number. So I've really moved it 1, 2, 3, 4, 5, 6 to get it bigger, and then I add in zeros where I need them. Okay, so our final answer was 3,497,000. Okay, do you want me to show that again? I write what I know, 3,497. I know my number needs to be bigger than 10, so I take my starting decimal point, I move it here to make my number bigger than 10. There's 3, 4, 5, 6. And then I add my zeros where they go, which means my final answer is 3,497,000. Okay? What did we get on the second one? Annie, what you got?
I just realized it was negative.
Okay, yeah, it does. It does. Okay, since this exponent is negative, what's that mean about our original number? It's less than 1. Okay, so I'm going to write out what I know. I want to make it smaller than 1, so I move my original place 1, 2, 3, 4, and I add zeros that way.
So I put zeros like behind it.
If you add zeros on this side, that's going to make it bigger than 10, which is not what we want. Okay, so our final answer should have been 0.00071. That was the number we were trying to express with this scientific notation. Okay, Jackson, what did you have for the last one? What was your answer on the last one? 100,000. Okay. So for this one, it's really simple, right? Just 5 zeros get added onto that one. Okay. We started with 1.0. We had to move it to make it bigger than 10. So 1, 2, 3, 4, 5. I'm going to fill in zeros as we go. So my comma goes there. 100,000. Agreed or not so much?